Welcome back to Scholars Academy. If you are preparing for your board exams, you are in exactly the right place. Today, we are tearing down one of the highest yield topics in your commercial mathematics syllabus, recurring deposit, or RD, accounts. Our objective is simple. We are going to dissect a standard RD word problem, utilize the core interest and maturity equations, and calculate the exact maturity value. Go ahead and grab a pen and paper. You will want to calculate these steps right alongside me. By mastering this specific four-step process, you will lock in 3 to 4 secured marks on your final board exam. Let's get to work. Take a look at this standard board question. Dhruv deposits 600 rupees per month for 5 years at an interest rate of 10% per annum. Step 1 is data extraction. The amount deposited each month is our principal, so P equals 600, and the rate of interest is our R, which is 10. That leaves us with the time component, 5 years. Stop right here. This is exactly where students lose their points. Plug the number 5 directly into the formula, and your calculation fails. This is the years trap. Time must be measured in monthly installments. We multiply those 5 years by 12 months, giving a true N value of 60. Make this an absolute rule for your exams. In commercial banking problems, time must strictly be calculated in months. The recurring deposit interest formula is I equals P times N plus 1 over 2 times 12 times R over 100. Drop the variables in. 600 for P. N is 60, making N plus 1 61. The rate 10 goes over 100. Looking at the sheer size of this fraction, it's easy to feel overwhelmed. Multiplying all of this straight across would be a massive calculation. So we don't multiply yet. We cancel. Start with the easiest targets and knock out the zeros. The 2 zeros in the 100 denominator cancel right out with the zeros in our principal. Next, look at the 12 on the bottom. We know 12 goes perfectly into 60, leaving us with a clean 5. Divide the remaining 2 into our 6, and the denominator is completely cleared. All that visual clutter collapses down into a simple string of multiplication. 15 times 61 times 10. Run that math, and we get an exact interest value of 9,150 rupees. Methodical fraction reduction is your best defense. Trying to calculate massive numbers before simplifying is exactly how arithmetic errors occur under exam pressure. With the interest secured, we can move to the final requirement, computing the total maturity value. Here is the second equation we need. Maturity value equals principal times N plus the interest. Look closely at that first section, P times N. This represents the total amount of money the depositor actually paid into the bank over the life of the account. A common mistake is taking the single 600 rupee principal and adding it straight to the interest. But Dhruv didn't deposit 600 rupees just once. He deposited it every month for 60 months. So we multiply his 600 rupee principal by those 60 months. His total contribution is 36,000 rupees. Finally, we take that 36,000 rupee contribution and add the 9,150 rupees in interest that the bank generated for him. The maturity value is simply the sum of every installment you paid into the bank combined with the interest that money earned over time. Add them together and we arrive at our absolute final answer, 45,150 rupees. If you calculated that same number, great work. By extracting variables properly, converting your time to months, and methodically reducing your fractions, you can crack any basic RD question on your board exam. But what happens when the examiners flip the script? What if they provide the maturity value up front and ask you to find the time? Suddenly, you're looking at a quadratic equation. It is a significant jump in complexity, but there is a clear process for that too. Click the video on your screen right now, and we will tackle that quadratic scenario step by step. Keep practicing, trust the method, and I will see you in the next lesson at Scholars Academy.